Hey everybody, how you doing? So the engineering challenge that I have for you today, or rather solution, because I already have solved the challenge, is a robust lever that does not look like Atomic Age or Dr. Frankenstein. So you can get big old levers, the blade switches, for what I'm doing here, but they look like Atomic Age or at least Dr. Frankenstein. We need something that looks more like a Da Vinci type of tech level for this. So what I've come up with is a magnetic detent contactless sensor. I'll crack this open for you in a second to show you how that works. But it kind of just wants to fall into place, and you should be able to see the little LEDs going back and forth, detecting up versus down. I've got a couple more modifications I want to do on this, but let's back up a little and go where I came from. Going back in time on design process, I have this way over large thing. And this is kind of on a prototyping video I made way back when. I mentioned that you don't want to use the material that the final is going to be made out of for the prototype to kind of force you to refine your design and not use your prototype as the final. And I kind of ended up going backwards on this version because the scrap material that I had laying around for the prototype is actually better than what I originally had in mind for the main thing. So if you can kind of look at that little slice there. The middle section is 3/4 inch, which is just monstrously oversized. And having to use this, the 1/2 inch Baltic birch, which incidentally, like yesterday at the time of filming, Adam Savage went on about, hey, this is the best material, and he's kind of right. This stuff is great. We had a bunch of awkward offcuts sitting around from a CNC job that we just did. So I had a bunch of this laying around to use for the prototype, and as it turns out, it's really good. I'm gonna finish getting prototype stuff out of the scrap we have, and then get some more of this for the actual pieces. But breaking it down, so we need a sturdy lever that is contactless and definitely goes into its position. So let's break this monster apart to kind of see how it's going to work. On this top layer here, we have the insert for the PCB that is the Hall effect sensor. So we're going to pop him off. And then we can kind of see into the working guts, where this will rotate around. This is going to be on a rod with a bearing and all that one. And we have magnetic detents here, so that when it's in that position, it's going to magnetically lock, and that'll put this magnet position directly behind where the sensor is going to go. And honestly, it's really, there's also some hard stops here to make this nice and robust. And for the handle, we're using file handles that attach to there. So you have a nice big handle to manipulate this lever with, and with that magnetic detent, you can really feel it locking into place. It's got good tactile feedback, and it's always going to go to a good position. This is the much smaller working version with one of the older FETs in there. And there you can see it doing its thing. And you can kind of see the handle wanting to go into place, and you can feel it lock. It's got that physical stop in there. So this is going to be burly. Nothing's indestructible, but this one should last a long time. So let's talk briefly about why I'm doing what I'm doing. On the back, I've got hexes milled into here so that you can just drop the bolt into there and it'll automatically grab. This makes assembling it a whole lot easier because you can drop the bolt in, the nut, bolt's not a word. So you can drop the bolt in, and that'll just be sticking through there, and then you can build up the whole frame on those pins. And the whole thing is milled out so that with the nuts in there, the whole thing should be flat. I gotta make these pockets just a little bit deeper because the washer is not letting the nut get all the way in, but that's why we're prototyping. Going in here, we have the actual movie bit. That's a technical term. Is that technically a rotor? And you can see that I have the detents in here for where the pull magnets are gonna be. We've got countersunk rare earth magnets One goes here, and then one goes on here, and that gives you that nice mechanical feel of it locking into place, which lets the player know something is happening, and also makes sure that this magnet and then that magnet actually register dead center on the actual Hall effect sensor. So I'm going to go play with this and see if that actually does what I want it to do, and then I'll come back and tell you how badly I failed. I love it when I'm right. So this has the pusher magnet in the middle there, so it's got that breakover point that you can feel that just makes the whole lever feel like it's doing something mechanical back there, and it kind of technically is. Because there's the pull magnet, and the push magnet, along with the one on the lever. So it just kind of breaks past that, and oh, it just feels so good. This doesn't need any other sound effects or anything. I like it. I like it a lot, and I'm gonna start making like 20 of these for these next games. You've probably heard the expression measure twice, cut once, but I'm gonna do you one better. It's measure however many times you need to get that measurement right, probably at least twice, and then using that, cut every time after that, because for most things, consistency is actually more important than accuracy. To that end, because we have a bunch of these that are all the same, we have this jig, which I think in one video Mark just said is technically a fixture, but I'm going to keep on calling it a jig because it's fewer syllables, even though I just used a lot of syllables to explain all of that. Anyway, this thing bolts onto this nice big heavy angle plate that holds this guy at a 90-degree angle. We have made sure that our deck is perpendicular to the bit here, and then this, along with this little guy here, that's going to hold our piece right here, so we can get a perfectly centered hole once this is all lined up for this magnet, and then in the same jig, if that magnet weren't in there, we can flip him around, and he's going to line up in there so we can get our hole up here that's going to center where our handle's going to screw into. And we have a similar fixture with all the mounting stuff on here to attach to the angle plate that will hold this one on there for that angle, for all three of these. It's all going on the same piece, and that way we know that our hole for the pilot holes on these guys, we're actually coming in through the back, just because we can't really get our tool into here. And this works. I know this because we've actually done all of this before shooting it and the sound crapped out. So here we are going back in time to re-explain fixtures, because that's relevant now. It's a thing. And we are now finally to the point where all of this painstaking, very minor tweaks on all of these actually pay off, because we have a whole big pile of these to put together. They're all the same, and they're designed to go together quickly from this point now that we have the parts. So step one is the base plate. It's got the hexes already milled in here to receive our 1/4-20 bolts. And they're snug, because Devin made them. Persuader stick. Oh, I'm sure that was great for the audio. And then I've got these really, really skinny little washer bushings. I think these are technically for electrical stuff, but they're the only ones thin enough, because I don't want the stator plate, the rotor plate, to be actually brushing up against the base and the carrier. So we've got really, really thin washers that go there, and then an even thinner washer, this little guy, who goes on that center pin that is the axle. So we can then take the stator plate with its magnets already in there, going, I think, south-north-south, or north-south-north. Doesn't matter, they're right. We got the rotor with its little plastic bushing in there. He goes in there, yep, and that one is correct. Then we get some more of our tiny-ass little washers. Gray for the middle, red for the sides. The carrier plate that has space milled out for the fesses, or fessies, which I just got new ones in, and they're in the bath right now. Our 1/4-inch washers, our 1/4-20 nuts, and then I teleport to the tool corral to grab a 5/16 wrench. 7/16. 7/16 is the proper wrench for a 1/4-20 because freedom units. No. Ready, tighty. There we go. And I really don't want to get this too tight. The ratchet's probably overkill. And now to do it 20 some odd more times. There's like 4 more down, 16 to go, but they go together pretty quickly, so we can get these punched out. And through the magic of movie, jump cut to we have an escape room puzzle. We've got a couple of more very similar stuff to do for these particular games that are going down to Texas City. But we got levers, they work, electronics is all in, so this right here, just add 12 volts and a mag lock. This is a complete puzzle. Now we're gonna make some more of them. I'm not gonna show you that because, well, you need to see this now and I'm not done with that yet. Have your content.